Hello, everyone, and welcome to our latest DZone webinar. My name is Jason Cockerham, and I'm the Community Engagement Manager here at DZone. And we're glad you're here with us today. We've got a relevant and an exciting topic, and so we're happy that you've joined us. If you're new to DZone, we are one of the world's largest online communities of software developers and experts. We publish all sorts of knowledge resources for developers and anyone passionate about software development. We've got everything from ref cards and trend reports to thousands of articles written and published by our community, making us the go-to knowledge hub for software developers all over the world. We also do a ton of great events like the one today, and you can find all of them at dzone.com/webinars. There you can see past events, you can see on-demand webinars, and we've got a whole range of upcoming events for you to look at too. So be sure to check it out. Joining me today is Taylor Smith. He is a senior product manager for Prisma Cloud by Palo Alto Networks. He helps customers integrate security into DevOps practices to secure the entire cloud native stack. And previously, he's held product marketing and strategy positions at companies like Gremlin, Cisco, and NetApp. He's going to be talking today all about secrets. But don't worry, we're not going to be asking anyone to divulge their darkest secrets, and we're not going to get really personal here. Taylor's just going to be talking about the secrets that people and companies want and need to be kept private, and some best practices for doing that. You know, as developers, we've all sort of been led to believe, or simply allowed to believe for years, that securing data often has to involve efficiency trade-offs, where you can either have super secure data that's buried under layers of encryption, but it takes a lot of time, effort, and resources to keep it that way, or you can have super efficient security processes, but then your data is not that safe, right? Well, today, Taylor is going to talk about some best practices for finding that balance, right? How do you meet in the middle? How can you safely store secrets without sacrificing efficiency? He's also going to talk a little bit about how we can identify secrets earlier in the SDLC so we can better protect them. And then at the end, he's going to answer any questions that might come up. We're all about community here at DZone, so we encourage you to get involved and get engaged in the conversation. On the right side of your screen, there's a little box where you can chat with other attendees about your own security best practices and some things that you've found over the years that either work or don't work. And there's also a box where you can submit questions to Taylor, and he'll do his best to answer as many of them as he can. At this point, I'm going to hand it over to Taylor. So Taylor, the floor is yours.
Awesome. Thanks so much. So I'm going to jump into it, and let's talk a little bit about secrets. And we're not, again, talking about your deepest, darkest secrets. What we are talking about is things like API keys, passwords, tokens, and these, if you're not familiar, which I'm sure you're all intimately familiar, these are really how you control system-to-system communication, or even how you as a user might access your terminal, might run CLI commands. So examples of these would be things like Artifactory credentials, database credentials, cloud credentials, secret passwords that you might have. And all of these are extremely sensitive. No matter how locked down they are, there's sensitive information that you may not know about that having access to these secret keys could get a bad actor to get access to. So really, any exposure of these secrets is bad, but let's talk about the amplitude of this. So Gartner, in one of their reports, mentioned that by 2024, they're predicting that at least 75% of attack pathways will involve an accidentally exposed secret. So we're not talking small scale here. We're talking about extremely important issue. Having your secrets exposed is really a primary problem. This makes it so much easier. There's no hacking involved. If an attacker is able to grab those secrets, they can use it and move around, pivot inside your environment, and do some nefarious things. So let's talk about why secrets get hard-coded and why would they potentially be in a repository to begin with. So I don't know about you, but when you go through and develop things, you're looking for, when it's not part of the actual code you're writing, you're looking I look for the simplest path. So an example of that is if I'm testing a service connection to a database, sometimes it's easier just to add in the password locally. If I have a container that needs to make a call to another service, let's say to Twilio to send text messages or something like that, it's just a lot easier while I'm programming just to add the key in an environment variable, and so I have it. Or if I'm about to provision resources for infrastructure as code, like with Terraform, You could add it into an environment variable locally, but what happens if you shut down, restart your computer, the environment variable gets wiped out, or you need to update those credentials? It's kind of annoying. So it's a little bit easier just to add it into the provider section of your Terraform code. And then what happens is you leave it there and it gets exposed. So let's talk a little bit about what might happen that would cause those secrets that you've added to be exposed. For example, if you forget to add the secrets or secret files, sorry, if you have the secret files that you store all your secrets, my super secret password.txt file, and forget to add that to your .ignore, then that gets uploaded into your repository like GitHub as soon as you make a commit and publish the branch. And then you might have added the images, added the passwords into the image itself, and then you make that commit to a registry, and bam, now that in just one of the layers of the image, you have a password. Or it might be by temporarily hard coding the passwords. This happens, this is what I was talking about. If you, just for testing purposes, you're debugging as fast as you can, you got to hit a deadline, you just add in your password, you want to temporarily add it, and then it becomes not so temporary because you forget about it. And you commit that code, it gets pushed to a public repo, and bam, it's exposed. Or another one that we've seen is you have, such as in CI/CD pipelines, or in when you're making a resource such as an EC2 instance in AWS or a VM and the other cloud providers that is allowed to provision other resources, you might just give it the credentials rather than going through the whole process of IAM permissions. And now when you've provisioned that resource and thrown it up into the cloud, it's exposed. Another example that we've seen is that you use Terraform to actually submit the password into KMS, into a key store. This is great. You're moving your passwords into a key store. That's what you should be doing, but you shouldn't be committing the Terraform code that pushes that password into KMS into a repo, because now it's exposed in that repo. And we're not just talking hypothetical here. Let's talk about some real world examples. So the most recent, very high profile one was Toyota. All that happened is they had some passwords that were in a private lockdown repo, fully firewalled off, all the best practices, did some great things, but that repo was able to be cloned, and a contractor took that clone and posted it to a public repo. Now all those passwords are exposed. So they put a lot of protections in place, and I hear this all the time. Well, my repo has some passwords, yeah, but we've locked down our repos, we're good. And the fact is, that's not enough. And then you have other examples, like recently NVIDIA and Uber and a lot of these other companies have their passwords or their credentials exposed, and it only takes, from one study we saw, it takes just a few minutes for a bad actor to search all of GitHub to find credentials, and immediately they have scripts that trigger on what kind of credential they found to ping a service and immediately do some bad things. So another example that we saw was there was just a blogger who had his own AWS account that he showed off technical things. He accidentally committed code pretty deep embedded into his code with AWS credentials, and overnight went to bed. Overnight he woke up and he had a bill for $100,000 in AWS. A bad actor had really quickly scanned, found his security credentials, immediately reached out to AWS and spun up a whole bunch of EC2 instances with GPUs and started mining crypto. And this is really the fundamental issue that we're trying to prevent. And it's not isolated to just one part of the supply chain. So if you think about how a supply chain works from the code build to deploy to runtime, each of the stages has its own potential opportunity for exposed credentials. In the code stage, you could simply commit code that has secrets in it. You could also have vulnerable packages that are linked to, maybe you've locked down credentials, but if you have a vulnerability that allows access to those credentials, then it could still see it, then a bad actor could still get access to it. You might have an image that you add into your repo, or that you add into your environment, and it is able to suck out passwords and send it out. If you have insecure configurations for your CI/CD pipeline, code a simple PR comment with unfettered access for unit testing could run scripts. And so now you have injection that could call out to any environment variables that could contain secrets and send that off to a bad server. And then finally in runtime, all of this could happen again if you have container images with embedded secrets in there. Or if you have virtual machines stored in local file systems, you have a secret exposed. Now a bad actor, if they get in, that's bad already, but if they have immediate access to secrets, credentials that would help them pivot to, say, a database or a privileged area of your environment, that makes it a whole lot easier for them. So this problem is across the entire supply chain. All right, now what do you do if you have an exposure? And this is important. Stop what you're doing, immediately revoke the key. And I'm sorry, this is gonna hurt. If you revoke a whole bunch of keys that you don't know what they have access to, and you don't know where they're being used, you're gonna break some systems. But this is what happens. Rotate the key, check for broken applications, and then re-add your keys where important using proper methods. All right, enough with that. What's the problem with existing security secrets detectors? Oftentimes what we see is there are security secrets detectors out there, but they're detecting late in the stage. They might be detecting at runtime only, or they might have a single dimensional approach. Maybe they just have signatures or a very, very weak, untuned entropy model. And maybe they have noisy findings where they've got very poorly tuned models. They have way too many signatures that are too broad, and they don't have finely tuned scanners. So what's the better way? Let's talk about this for a second. I've broken it down into 4 overly simple, granted, ways you can improve. So the best way, honestly, is to identify those secrets and flag them as early as possible, making sure that it's embedded in the tools that developers are already using. So don't make them go into a separate tool. If I'm working on something, I'm not going to leave my tools to go to something else to make sure I'm not committing a secret. Embed it in the developer tools. Do this across the development lifecycle. So as you're developing in your IDE, have that flag for, hey, I've got a security issue here. I've got some secrets exposed. Now, I may be doing that quick path that I was talking about before, where you are adding hard-coded credentials just to save time. And I might be aware of that, but it's nice to have that flag right there and then. And then in your pipeline, so having that pre-commit hook. So before you actually commit code to a public repository, you can have hooks that say, okay, I noticed a secret, let's block it, never let that secret into a public repo. And then again, as another layer, if it gets past those systems, the manual human being told, don't commit the secret, and then the pre-commit hook, maybe it still might get by, have again repository checks. So you're checking for secrets periodically, making sure that there's no exposed secret that you're not aware of. And then at runtime, so sometimes, again, it gets through all of these checks. Maybe it's very deep in a container image, and so it's just not spotted. Make sure at runtime you're also having scanning, so you're detecting those secrets. So across the entire development lifecycle. All right, have a multi-dimensional approach with noise reduction. So really, it doesn't work to just rely on signatures alone. These are great. Regular expression signatures is what we use. This is great for identifying known secrets, and it will detect quite a few of them. It's also highly accurate if they're tuned and written correctly, but that alone won't do it. Similarly, if you have a pure entropy model, this is where you're checking that if there's a string that it looks nothing like the English language, you can check and say, okay, this is most likely a password. It's in a key value pair, or if it's in YAML, it might be in multiple lines. It detects that based on the context, and then it can use entropy to say, okay, this is nothing like the English language, flag this as a secret. So a good example of this I stole from XKCD, correct horse battery staple. It's a nice password. If there was a sentence, nothing wrong with it, it's English, but that shoved together into a single line is not really the English language, it's most likely a secret. And finally, validate those secrets. So this will save you a ton of time, especially with how noisy, no matter how good your secrets detector is, you're gonna spot maybe even valid tokens that have expired. And so having that validation where you can take a secret, send it off to the service without doing anything that would require privilege, but you can just ping certain services and say, okay, is this token usable? And if it's not, then you can immediately eliminate that. Say, okay, great, it's a password, I probably shouldn't, or an access key, an API key, I probably shouldn't have it in my repo, but at least I know it's not a high priority. Or it hits the service, it returns a response code of 200 or whatever response code makes sense. Then you know, okay, this secret is not only exposed, but it is valid. This is my highest priority. I need to get this fixed now. And that will save you a lot on that noise reduction, making sure even if you find a signature, you know where to start. And then limit the blast radius and monitor for abuse. So this is kind of the what do you do as a parachute if something goes wrong? You want to proactively limit and monitor for abuse. So right-sizing permissions for any of your access keys or API tokens is critical. Making sure that if you have an access key, let's say for a cloud account, making sure that cloud account only has permissions to what it should have permission to do. This is important. That way, if an access key gets exposed, the blast radius is minimized because that bad actor still can't access much, can't do much. A very common example of this is if you're able to pass roles or spin up other resources, if you're able to create resources, bad actors will use that to pivot and escalate their role over time. So let's say they start with a very minimal role, they get the credentials, they steal your credentials either from an exposed secret in a repository, or maybe they found credentials in a VM. They use that to create other resources, let's say another VM with escalated privileges, they gain access to that, and then so on, so on. So they kind of ping pong up and up and up and up until they have more and more permissions until they can do something really bad. And then it's really important as kind of that final safety net to monitor for abuse. So you've put all these controls in place, that's fantastic. You've done all the right things, you're catching secrets, you're preventing secrets from being committed. At the end of the day, no one's perfect. A secret gets out there, it gets exposed. Make sure you have the right monitoring in place. Make sure you have UEBA, user behavior monitoring. Make sure you're detecting if there's any anomalous activity or abuse. All of these things combined together will really protect you even in the case of a breach. And then of course, make sure you have the tools in place to investigate if there is an issue, if there is a secret exposed. And then finally, but really as important as any of the others, make sure you have a better alternative and make it as easy as possible to use it. So instead of using hard coding credentials, make sure it's as easy as possible. Make sure you have a vault or a KMS, some sort of secret store that's very easy for developers to get access to and easy for them to use. So make sure they have the right training. So instead of what I was showing where you've just hard coded in the credentials to have a container access a database, or for Terraform to spin up a whole bunch of resources, use Vault as the interim to basically secure those secrets and have them just in time added and secured. And make sure you have the right tools in place to inject those secrets, especially in the container environment, inject those secrets right as they're needed and not before. That way, if a container is breached or if a repo is exposed, those secrets are not in there. Let's talk a little bit about that. So this is my easy example, very, very silly example, but I've been guilty of it. In the provider section of Terraform, if you want to make your life simple, you can add provider AWS and add your AWS access key and secret key. And for you folks who are watching this, don't try and abuse it. You can see it's got example at the end. I'm not dumb. So instead of that, you can use Vault as an example, or use your CI/CD system to run its environment variables. And even if you're doing this testing where you are running Terraform and you're doing some local development, you want to get the plan file that requires access to your AWS environment, make sure the provider.tf or whatever you've called that file with the provider, make sure that's in git-ignore. That way it's never committed to your repo. Better practice would be use a key store. Make sure those secrets are not exposed. I wanted to show a quick example of this. So this is what I was talking about. When you're in your provider.tf file, it's very simple to just simply say, rather than go through the pain of adding in my vault or whatever, I'm going to just add my access key. And now if I do a Terraform file, if I do a Terraform plan, it's right there. I've got everything I need. The right tools will make sure that you've got these flags. So in this case, AWS access key is flagged, or high entropy if it's a secret or a password that's not signature based. Make sure those are flagged in the development environment. So it's a good reminder of, yeah, I'm using it for dev testing, but okay, I need to remove this before I push to prod. Another example I wanted to show real quick is just running a quick scan on an entire repo. You can see this was just a silly dummy repo that I found. I found a dozen or so secrets in it. So making sure you detect those secrets. Now, all of those were revoked or null secrets, but it's still not good to have those exposed. And it just shows you an example of how having all of that, how easy it is just to expose your credentials and have them out there and present. All right, so that's what I had. Thank you so much for listening and watching. If you have any questions, please add them. You can also check out what we offer for secrets at Prisma Cloud at this website, prismacloud.io/prisma/cloud/secrets security. You can also follow us on Twitter at Prisma Cloud.
All right, thanks, Taylor. We did have a couple of questions come through. If you have a few minutes to answer some questions for us.
Sure.
Let's see here. So the first one, what do you do if the initial scan picks up hundreds of secrets? Where do you start?
Yeah, so I've had a few customers where I first brought in for a POC, I've brought in our product and just said, okay, let's just run and see what happens. And they picked up on hundreds of secrets. I think it really comes down to prioritization. So step one is start preventing. So get those tools in place across the pipeline that I was showing before. Make sure you minimize the amount of new secrets that are getting added. Make sure you have that education or with your developers of how you do it instead. And then it's about prioritization, going through those hundreds of policies, seeing which ones are valid, and those hundreds of secrets, seeing which ones are valid and starting with those, seeing what the damage would be if it was exposed, and wherever possible, start revoking and rotating and switching out to a better solution like Vault.
Yeah, makes sense. Yeah, that's everybody's worst nightmare, to find hundreds of secrets just hiding there waiting to be.
It seems quite easy to say, don't add secrets, but it seems to be a common thing that everyone does.
Yeah, I don't know why we can't seem to learn from our mistakes, but it's just part of how it goes. Okay, what about secrets stored in private repositories?
Yeah, so we touched about this a little bit in the beginning with companies like Toyota. Even when I hear this all the time of, okay, yeah, I've got secrets, but I've got a completely locked down repository. I'm not super afraid of what happens if it gets exposed. The problem with that is you still have some bad actors who might, maybe with the best intentions in the world, copy those passwords down and then add them to a public repo, or might for their own testing, or maybe they want to show off their work that they've done. And so they expose the secrets. If it's in a repo and you have users who can view it, then you are exposed. That's a problem.
Yeah, I think, I've heard it said several times from security experts and colleagues of mine that just always assume that there's never a perfect solution, right? So it's almost like with always assume the gun is loaded, always assume the secrets can be accessed, right?
That's right.
There is no perfect security solution, unfortunately. Okay, and then one more question: how do secrets tools fit in with other security tools?
Yeah, absolutely. So this is a good question. I think secrets tools on their own are quite valuable, just finding different secrets and exposing them. When they're embedded with other tools, it really simplifies the operation. Operating these tools. So if you have others code scanners and they're doing the secrets, now you don't have two different tools you have to manage. It's a little easier to tune them and bring them into your environment if you already have, let's say, a code scanner for other things like SCA or IaC scanning. So there's some complement there also for context. So if your secret scanner is able to add some context for not only is this a secret, but it's in an IaC file or something like that, that just simply running a secret scanner alone wouldn't pick up on, that additional context is pretty helpful for prioritization.
Okay, cool. Looks like we have a couple more questions from the audience or the viewers today. So what is the secret models?
I'm not sure I understand the question.
Yeah, not quite sure there either. If whoever asked that question, if you could maybe provide a little bit more context, that'd be great. We'll skip this other one, give them some time, maybe add a little more context. One more question here. Wouldn't it make sense to use Vault or something similar for dev and QA testing as well? This would prevent any errors and put the process in place early on.
Yeah, absolutely, 100%. I always say the best practice is just to use Vault throughout. Don't ever hard code your secrets because you're going to make mistakes. You're going to forget to add the file to the .ignore, the .get ignore. So absolutely, from the beginning is best. Start with best practices from the beginning, and if you can do that and switch to that methodology and that practice, it will save you a lot.
Yeah, kind of again, just adopting that mindset of, the earlier you can bring security practices into the SDLC, the better it is. It's not necessarily creating something new. It's just taking the security practices that dev and QA process or practice all the time and bringing them as early as you can into the SDLC.
Yeah, absolutely.
Okay, so I think it was meant to say what are the security models and not the secret models. So I think maybe he's asking about what maybe some specific models that you might be referring to, or
I'll see if I can answer that. I'm not sure I completely understand the question. So if we're talking about other security tools that are linked to secret scanners, I would say if you already have a tool that's running code scanning, then you can leverage those. So oftentimes you have tools like software composition analysis that is running over your code already, or at runtime if you have a runtime protection tool, let's say like an agent in line or out of band, some scanning, using those same tools rather than a dedicated secrets manager will help with that, simplify the process of managing and everything, and if possible, add some context. So hopefully I answered the question. I'm not sure I completely understood it.
Yeah, well, he actually added a little bit more context. So I think so. He's asking what are the security models and the best security architecture and what security framework. So maybe I think he's asking maybe to provide some suggestions or models of kind of what's worked for you around architecture and framework and that kind of thing.
Sure. Yeah. So absolutely. The previous question about Vault and why not use it from the beginning. I think that's really the best practice is. Have a tool like Vault, or all the cloud providers have their own secret storage managers, or there's other vendors out there, other open source tools that you can use to store secrets. Use it from the beginning as much as possible, And where it's not possible, or you're trying to move too quick, whatever the reason is that you don't want to use it, you may not have access. So one of the ways I've seen issues with this is if your production vault you don't have access to, only CI/CD systems do. It's pretty good practice. Make sure you have the kind of the dummy variables in place that can swap them out. So if you're referencing a local vault, then you can swap those variables out for the production vault. And I've seen a few customers out there who actually have kind of a find and replace for local or dev test vaults and the production vault, where the CI/CD will make the switch for you. Yeah, so definitely wherever possible, don't add your secrets in public repositories, obviously, also not private repositories. And if you have secrets stored in, let's say, the CI/CD provider itself, we saw this with the recent issue with Circle CI, make sure you have the right monitoring in place, because even the best tools out there have had breaches, and so it's always good to make sure you have monitoring, make sure you're ready to rotate secrets on the drop of a hat. I would say also making sure you go through the practice of practicing rotation. So I have a few customers who kind of go through, and even if they have no exposure at all, they go through and they kind of randomly pick a dev team to say, okay, we're rotating all your secrets, get ready, and it better not break things. So just be ready for that, because if there is a breach, that's the first step, is revoke the secrets. So be ready for that and make sure there's no breaking issues.
Yeah, that's a good point. Again, a lot of security starts with the right mindset, right? A lot of it is just kind of putting the practices, staying in that mindset of, always, it's not just a one and done, right? It's an ongoing living thing.
Absolutely.
And that asker did say that was clarified, so we're good to go. And we do have one more question. I think we have a couple more minutes. It said, so I use the vault to secure the keys and the other secrets. Well, how do we secure the master key of the vault, right? Like, what do you do with that?
Yeah, absolutely. So this is where kind of the best practice is to have limited access. So you might have certain users with admin, very limited group, and have them heavily monitored. And then other users with very limited access to maybe just a few portions. So you can do like directories in Vault and have them have limited access. So that's locked down. And then have kind of the final admin credentials only accessible through services. No user should be able to access it. Of course, those we've seen in certain CI/CD breaches, those can be exposed. So again, be ready to rotate those master passwords and have a contingency plan in place if those master passwords are exposed.
Cool. Just kind of maybe for my own edification, and maybe also for some of this here, what's your recommended time frame for like rotating those secrets? You say once a quarter, once a month. I mean, is there like a best practice time frame for when that should happen?
Yeah, it's a good question. I don't think it's a one size fits all. It depends on your team and how often and the criticality of the environment that the secret is exposed to. So if it's a secret for a dev database that it has no real value, maybe just for good measure, rotate it every quarter or so. The customers that I was talking about who have kind of gone through the kind of random choose and rotate, they were on the they had a lot of that automated rotation in place with tools like Vault, and so it was just rotated, I think, on a monthly basis, most of the tools. And if you have that automation in place, it saves you a lot because it'll rotate the passwords without you having to do much. And yeah, so no one size fits all, but definitely the more critical the environment, the shorter the expiration date should be on any secret.
Cool, makes sense. All right, yeah, lots of good questions. I think those are all the questions we have that came through. If you do have one that comes up, after the webinar, you can feel free to reach out to Taylor and his team at Prisma. They'll be happy to follow up, answer any questions, connect with you offline, that kind of thing. So other than that, I think I just want to say thank you so much, Taylor, for joining us. And thanks to everyone else today for watching. Don't forget to check out our other webinars at dzone.com/webinars. We've got all kinds of events, and again, all of them are about really great and relevant topics just like this one. So I'd highly encourage you to check that out. We've got a lot of events coming up for this year, so you're definitely gonna want to check out that. Thanks again. I think that's it for us. You guys have a wonderful rest of your week, and we will see everyone next time.
Awesome, thanks.
Thanks, Taylor.